Okay, so next topic is inverse transform. This is the last topic from this chapter. So the formula is, if Laplace transform of f of t is capital F of s, then inverse transform of f of s, this will be f of t. As it is obvious from the name, inverse transform means fs is given and you have to find the function whose transform is f of s. So here again we are going to see total 7 formula. The first one is, we all know that Laplace transform of 1 is 1 by s. So this will mean inverse transform of 1 by s, this will be 1. Okay, transform of 1 is 1 by s. So inverse transform of 1 by s, this will be 1. So this is our first basic formula. The second one is, we know that Laplace transform of e to the power at, this was 1 by s minus a. Right, this was the Laplace transform of e to the power at. So this means inverse transform of 1 by s minus a, this will be e to the power at. Okay, transform of e to the power at is 1 by s minus a, inverse transform of 1 by s minus a, this will be e to the power at. Similarly, our third result was Laplace transform of t to the power n, this was factorial n by s to the power n. Obviously this was the formula when n is any positive integer. So this means if I have to calculate inverse transform of 1 by s to the power n, now suppose if I had n minus 1 here, then I will get n minus 1 factorial here and s to the power n here. Okay, so if I want to calculate inverse transform of 1 by s to the power n, then this will be t to the power n minus 1 by n minus 1 factorial. Okay, inverse transform of 1 by s to the power n, this will be t to the power n minus 1 by n minus 1 factorial, because the Laplace transform of this function will be 1 by s to the power n. So these are first 3 formula. Then the fourth one is, we all know that Laplace transform of sin at, this was a by s square plus a square. Right, this was the formula for Laplace transform of sin at. So this means inverse transform of 1 by s square plus a square, this should be sin at by a. This will be the formula for inverse transform of 1 by s square plus a square, because if we take a here, then Laplace transform of sin at by a, this will be 1 by s square plus a square, and this means inverse transform of this function will be sin at by a. So this will be our fourth formula. The fifth one, we know that Laplace transform of cosine at, this was s by s square plus a square. So this means inverse transform of s by s square plus a square, this will be cosine at. So these are our first 5 formula. The next 2 are based on hyperbolic, sine and cosine. So our sixth one is Laplace transform of hyperbolic sine at, this will be, this was a by s square minus a square. Right, Laplace transform of hyperbolic sine at was a by s square minus a square. So this means inverse transform of a by s square minus a square, or maybe I can write 1 here. So this will become hyperbolic sine at by a. Okay, if I divide by a, then I will get 1 here. So Laplace transform of hyperbolic sine at by a is 1 by s square minus a square. So this means inverse transform of 1 by s square minus a square, this will be hyperbolic sine at by a. And the last formula that you need to remember is Laplace. This formula you don't have to remember separately. Once you know the formula for Laplace transform, then you can easily calculate inverse transform. So Laplace transform of hyperbolic cosine at, this was s by s square minus a square. So this means inverse transform of s by s square minus a square, this will be hyperbolic cosine at. So these are the total 7 formula that you have to remember. And obviously sometimes you also have to use first shifting property. For example, suppose if the question is, say we all know that Laplace transform of e to the power at sin bt. Now what should be this value? So using first shifting property, first we have to write Laplace transform of sin bt. So for this the formula will be b by s square plus b square. Now if this sin bt is multiplied by e to the power at, then you have to replace this s by s minus a. So this will be Laplace transform of e to the power at sin bt. Now suppose if you have to calculate inverse transform of 1 by s minus a square plus b square. Okay, so now this will be simply e to the power at sin bt and this divided by b, right? Because if I divide by b, I will get 1 here. So inverse transform of 1 by s minus a square plus b square, this will be e to the power at sin bt by b. So these are some of the important results related with inverse transform that you need to know. Now we'll take some problems, and with the help of those problems we'll see how to apply this formula. Okay, so now we are going to see these two problems. The first question was asked in GATE 2012 in mechanical, the second problem in GATE 1996 in EC. So the first question is, the inverse transform of this function is given by fs is 1 by s into s plus 1. So we have to find the inverse transform of this function. So see here, the first step will be, we know that Laplace transform of inverse transform of 1 by s minus a, this was e to the power at, because Laplace transform of e to the power at, that was 1 by s minus a. So we have to use this formula, but before that we have to separate this denominator, we have to do the partial fraction of this. So our capital F of s is 1 by s into s plus 1. So this you can write as a by s plus b by s plus 1. Now if you take LCM, so you will get s into s plus 1 in denominator, a into s plus 1 plus b into s. Now if you equate the numerator of these two, then you will get a into s plus 1 plus b into s, this should be 1. Now by substituting different value of s, we have to find the value of a and b. So if I substitute s equals to 0 here, okay, if I place s equals to 0 here, then I will get a into 0 plus 1 is 1. So this means the value of a will be 1. And if I substitute s equals to minus 1 here, minus 1, because then this term will become 0, we will get the value of b. So if I substitute s equals to minus 1 here, then I will get a into 0 plus b into minus 1 is 1. So this means value of b will be minus 1. So now your fs will be, in place of a you have 1, b is minus 1. So this means fs will be 1 by s minus 1 by s plus 1. Okay, in place of a I am writing 1, in place of b I am writing minus 1. So this means inverse transform of f, L inverse of f of s, this will be, we all know that Laplace transform of 1 was 1 by s. So inverse transform of 1 by s will be 1 minus, now here this is s minus minus 1, so this will be e to the power minus t. So Laplace inverse transform of f of s, this will be 1 minus e to the power minus t. So this is our option D. Now after this we have another problem, this was asked in GATE 1996. So here also we have to do the same thing. Our f of s is s plus 5 by s plus 1 into s plus 3. So this we can write as a by s plus 1 plus b by s plus 3. This thing is called partial fraction. We have to write this in terms of two, we have to separate the denominator. Here you have product of two linear factor. So we have to write some constant by first linear plus another constant by second linear. So now here if you take LCM, then you will get s plus 1 into s plus 3, s plus 1 into s plus 3, this will be LCM, and we'll get a into s plus 3 plus b into s plus 1. Now if you equate the numerator of these two, then the relation that you will get is a into s plus 3 plus b into s plus 1, and this will be s plus 5. Okay. So again by substituting different value of s, we have to calculate the value of a and b. So if I substitute s plus 1 equals to 0, meaning s equals to minus 1, then this term will become 0, will get the value of a. So a into minus 1 plus 3, this will be 2, and this will be minus 1 plus 5, 4, which means the value of a is 2. Now we need to calculate the value of b, so for which we can make this term 0. So for that we have to substitute s equals to minus 3 here. So now this will become 0, we'll get b into minus 3 plus 1 minus 2, and right hand side will be minus 3 plus 5 plus 2. So from here the value of b will be minus 1. So now once we have obtained a and b, our fs will be a is 2, so 2 by s plus 1, plus b is minus 1, so minus 1 by s plus 3. This will be our f of s. So f of t, or the inverse transform of f of s, this will be 2 into, now s minus minus 1, so this will be e to the power minus t, minus s minus minus 3, so e to the power minus 3t. So now as far as the options are concerned, our option A was with minus sign, option B with plus sign, option C minus sign, option D plus sign. So here we are getting 2 into e to the power minus t minus e to the power minus 3t. So this will be our option A, 2 into e to the power minus t minus e to the power minus 3t. So correct answer for this question will be option A. So this was last problem on inverse transform. Now after this we have to talk about initial and final value theorem. Okay, so next concept from this chapter is initial and final value theorem. So this initial value theorem is, these theorems are used to calculate the value of f of t and f of s. F of t is known at 0. If we have to calculate f of s at infinity, then here the formula will be limit t tending to 0 f of t. This will be limit s tending to infinity s into f of s. This f of s is nothing but Laplace transform of f of t. So this theorem is called initial value theorem, and the final value theorem is limit t tending to infinity f of t is limit s tending to 0 s f of s. Remember that if t is approaching to 0, then you have to write s approaching to infinity, and if t is approaching to infinity, then you have to write s approaching to 0, and this fs is always multiplied by s. Now with the help of one problem, we'll see how to apply this formula. So this question is given f of s is Laplace transform of f of t. The expression is 2 into s plus 1 by s square plus 4s plus 7. The question is find initial and final value of f of t. This problem was asked in GATE 2011. So we need to find the initial value of f of t and final value of f of t. So initial value of f of t, this will be limit t tending to 0 f of t. This will be the initial value of f of t, right? Now using this initial value theorem, we can write this as limit s tending to infinity s into f of s. So this will become limit s tending to infinity s into, in place of f of s we have 2 into s plus 1, and this divided by s square plus 4s plus 7. So we need to evaluate the value of this limit. Now we know that when s is approaching to infinity, this is infinity by infinity indeterminate form. So we have to take highest power of s common from both numerator and denominator. So if I take s common from here, I will get s into s square, 2 is constant, I will get 1 plus 1 by s, and from denominator if I take s square common, then I will get 1 plus 4 by s plus 7 by s square. Now this s square will cancel. If s is approaching to infinity, 1 by s will be 0, 4 by s will be 0, and 7 by s square will be 0. So finally you will get a 2 by 1. So this means initial value of f of t, this will be 2. Now the final value of f of t, this will be given by the formula limit t tending to infinity f of t, and this you can write as limit s tending to 0 s f of s. So this will be limit s tending to 0 s, and in place of f of s we'll have 2 into s plus 1, and this divided by s square plus 4s plus 7. Now if you substitute s equals to 0 here, then your numerator will become 0 because you have s into this quantity. So numerator will become 0, and in denominator you will get 7. So since this is not indeterminate form, you can directly substitute the value of s. So initial value will be 2. This thing is initial value. So initial value of f of t, okay, initial value is 2, and the final value of f of t is 0. In the problem options were given. So you can find the correct option. The answer is initial value is 2 and the final value is 0. So this theorem was initial and final value theorem. After this we have one last topic from this chapter. We will learn how to solve differential equation using this Laplace transform. Okay, so our last topic from this chapter is to solve differential equation using Laplace transform. This concept we will see with the help of one problem. This problem was asked in GATE 2013 in mechanical. The question is the function f of t satisfies this differential equation d2f by dt square plus f equals to 0, and the boundary conditions that are given are f of 0 is 0, f dash 0 is 4. Now the question is the Laplace transform of f of t is, we have to find Laplace transform of f of t. So 4 options were given. I am not writing the options here. So here the given differential equation is f double dash t, d2f by dt square means f double dash t, plus this is some function of t, so f of t, this equals to 0. This is our given differential equation. Now for solving a differential equation using this Laplace transform, the first step will be you have to take Laplace transform on both sides. In the given differential equation, in this equation you have to take Laplace transform on both sides. So you will get Laplace transform of f double dash t plus f of t, and this equals to Laplace transform of 0. Now say the Laplace transform of this function f of t, this is capital F of s. Suppose if Laplace transform of f of t is capital F of s, then Laplace transform of second derivative of t, the formula that we have seen earlier was s square f of s minus s into f of 0 minus f dash 0. This will be the Laplace transform of second derivative of t, plus Laplace transform of f of t, this will be capital F of s, Laplace transform of 0 will be 0. So these three terms we are getting from this single term, Laplace transform of second derivative of t, s square f of s minus s f of 0 minus f dash 0, and Laplace transform of f of t is f of s. Now if you substitute the values, then from these two you can take f of s common, so you will get s square plus 1 minus s into f of 0 is given, f of 0 is 0, so you will get 0 here, minus f dash 0 is 4, this will be equal to 0. So from here you can easily see that you will get f of s, this equals to 4 by s square plus 1. So the answer to the given problem will be 4 by s square plus 1. Laplace, this capital F of s is nothing but Laplace transform of f of t. The question was calculate Laplace transform of f of t. So this will be 4 by s square plus 1. But suppose if the problem was we had to solve this differential equation, then solving differential equation means finding this function f of t. So first we have calculated the Laplace transform of f of t. Now the solution of the differential equation is, solution of differential equation, this will be f of t. So how to calculate f of t? F of t will be nothing but inverse transform of f of s. So this will be inverse transform of f of s is 4 by s square plus 1. If you take 4 outside, then inverse transform of 1 by s square plus 1. So this will be nothing but 4 sine t. Inverse transform of 1 by s square plus a square, this will be sine at. So this is your f of t, and this will be the solution of the given differential equation. So the answer to this particular problem will be Laplace transform of f of t is 4 by s square plus 1. If the question was solve this differential equation, then solution will be this 4 sine t. This function 4 sine t will satisfy this differential equation. Okay, if you want to verify, you can easily see here that this is f of t, f dash t will be 4 cosine t, f double dash t, this will be minus 4 sine t. If you add these two, then you will get the given differential equation, f double dash t plus f of t, that will be minus 4 sine t plus 4 sine t 0. So this was the last topic from this chapter.